Hello folks, welcome to this series of AWS services, and we are talking about networking and VPC. By now we have seen that how a VPC works, what are the major components of it, how to secure your VPC, what is a subnet, what is a network access control list, and how network access control list is different from security group. Since now we have got this much idea, let's go and create a VPC which has multiple subnet, which is using things like NAT gateway, internet gateway, customized route table, and customized network access control list. So in this video, we are going to create a architecture something like this. So we'll have a public subnet, we'll have a private subnet, we'll have a NAT instance running in the public subnet, and we'll create public instances and private instances in both the subnets. So to create this, I'm going to use again VPC wizard, which gives you a ready-made way to create an architecture. But once we create this, we'll be able to see the concepts, that how these various components collaborate and create a secure ecosystem where further AWS resources can be launched and can be managed. So let's move on to our aws.amazon.com, log into console, and here we are. Let's go to VPC dashboard. I'm going for VPC wizard. So to show you the fresh region where I have not created any resources, I have changed my region to Singapore. So in the Singapore region, there are 3 availability zones, and the resources which are created here, they are the default resources. These are the default resources. So this is a fresh VPC where nothing has been created. So we are going to start from the scratch. So I'll start by VPC wizard. And here if you see the second option, it is creating a public subnet, a private subnet, and there would be a NAT instance, or you can have NAT gateway inside the public subnet. So this is providing as a /16 VPC network, and the subnet which consists of this VPC have /24 subnets. We are using elastic IP here to attach to the NAT instances or the NAT gateway. So we'll be going ahead with the NAT gateway here. So let's start by selecting it, and here you go. This is the CIDR block of the VPC, IP address range of the VPC, which is /16, means 65531 IP addresses are available here for use. Now you can go ahead for IPv6 CIDR block as well. In that case, you need to know that what is the formatting of IPv6. I'm going ahead without IPv6. So I need to give a name to this VPC. So I'm going to call it my custom VPC. Now since there are 2 subnets here, public subnet and private subnet, we need to provide the CIDR block for both. And for the first one, it is this 10.0.0.0/24. What is the availability zone for it? So we can go ahead with no preference, but I'm selecting here AP Southeast 1A. The name of this subnet, I'm going to write custom public subnet. Same things I will repeat for the private subnet. I'm going to create it in AP South 1B, and I'm going to name it custom private subnet. Now for my NAT gateway, we need an elastic IP. So here nothing is showing here right now. So we'll go to our EC2 management console in the same region, and then go to elastic IPs and allocate a new address. Just allocate it 52.220.27.162. And now if you come here, I can see an elastic IP here. So elastic IPs work similar to static IPs, which means you have reserved this public IP to use it for NAT gateway. So when I do this, it is also getting attached to the NAT gateway that will be created. We are ignoring this service endpoint for now. Enable DNS hostname, and then what is the hardware tenancy. We have seen these things. Now I'm going to create a VPC. This will take some time. So what exactly it is going to create is, it's creating a VPC, it's creating 2 subnets. Along with the VPC, it will create a default network access control list and a main routing table. Also, it is creating NAT gateway. It is assigning that elastic IP to that NAT gateway and doing other configuration steps. Now please remember that it would not by default create any instance. So we will have to create instances for the same. So we'll wait here for it to complete. So once completed, we can see this screen. It's asking us to launch new instances. Our VPC creation has been completed. So now we can go on our VPC dashboard and see the difference. Now we've got 2 VPCs, 1 default plus 1 custom VPC, 2 internet gateways, 3 default subnets in the default VPC, and 2 subnets in our VPC, so total 5 subnets, one network ACL in each, and it seems we have created 2 route tables. So let's go on and see our subnets. You can see here 2 custom subnets have been created, one public and one private. Here you go. This is my custom public subnet, and this other one is my custom private subnet. Rest of those 3 are the default ones, meaning they are of default VPC. If you see internet gateways, again you can see here that one new internet gateway has been created and has automatically been attached to this VPC. Remember, all this configuration is provided by the VPC wizard, which you may not use in the industry. You might have to create your own VPC and then create internet gateway and then attach it to the VPC. But here all that task is being done by the VPC wizard. So internet gateway is there. If you see now the route tables, so we can see here 2 route tables has been created. One of them is main route table, and then we have got another route table which is a custom route table. So you can see it here. Let's look at the custom route table first and see the routes in it. So here you can see that if the destination is anything within the VPC, then the target, that is the next hop, is local, which means they can have direct connectivity with any instance within the same VPC. However, when the IP address is a universal IP address, which means it can be addressed from internet, then the target is internet gateway. Now this we are talking about here, custom route table. This will apply on custom public subnet. And this is very important here. The routes that are given here, they will be applicable on the custom public subnet because that has been directly associated. This is also showing information about the other subnets where it is saying the following subnets have not been explicitly associated with any route table and are therefore associated with the main route table. Now, what is the main route table? Main route table is the next one. So now let's see how main route table has been created. So here you see, for any destination within the same VPC, you have got the target as local, which is same as a custom route table. And this is always same whenever you create a new route table. For instances within VPC, you will always get this rule. What about the addresses which are not in this range? They can be anywhere from the internet. In that case, the target would be NAT gateway here, and this is important. As we have been saying in the NAT gateway videos that it's not sufficient to create a NAT gateway, you also have to provide a route towards NAT gateway in appropriate route table. So we have created this route for the NAT gateway, and here you can see that which are the subnets on which this route will be applied. Now since it is main route table, so though it is not explicitly associated with the private subnet, but since private subnet is not associated to any other route table, so all these routes would be applicable on the private subnet. And here it says, the following subnets have not been explicitly associated with any route table and are therefore associated with the main route table, which is my private subnet. So any instance in this private subnet will follow these routes. So this route is the responsible route for facilitating internet access to even your private instance. The traffic towards the internet from the private instances is going via the NAT gateway. For outside internet, it seems that the traffic is directly coming from the NAT gateway, and so it's a response in the same way. But when the response comes to the NAT gateway, it gets forwarded to the private instance from where the original request initiated. To look at the NAT gateway once again, we can just click on this, and here you go. This is our NAT gateway. This is elastic IP address that we created before even creating the NAT gateway. Now it is attached to the NAT gateway, and this is the private IP address of the NAT gateway. So once everything is done, what we can do is we can create instances in the public subnet as well as the private subnet, and we can check whether the network connectivity is there or not. So let's go to the EC2 management console and create an instance. So I'm going to first create a public instance in the public subnet. Only thing we need to change here is that now we'll be selecting the custom VPC and the custom public subnet. Make sure that we do assign a public IP here. Now in the subnet setting, it is disabled, which is a bit not up to the standard. If we want to make it enable, we should actually ideally go to the subnet, go to the public subnet, and here in the subnet action, we should modify auto assign public IP setting. So ideally we should, if we have created some public subnet and we want every instance in it to have a public IP, then we should enable auto assign public IP. Click on this and save it. Now this may not appear right now, but in the next cycle it will appear as the subnet setting would be enabled for public subnet. For private subnet, of course, it should be disabled. So I'm enabling it, and that's all. My public instance. I'm just putting HTTP just for the sake of it. Create a new key pair. My Singapore key pair. Key pairs again are region specific. So if you are creating a new instance for the first time in a new region, then you have to create a key pair and you have to download it. I just download it. I can launch the instance now. Meanwhile, I'll use Puttygen to convert this key pair into a .ppk format. My Singapore. Okay, save private key. Now again, please remember that if you are using Linux or Mac systems, you don't have to do this step, converting them file to ppk file. Okay. I can now use normal putty to connect to the instance. Select proper ppk file and open. And here you go. EC2-user. That's all. So now I'm connected to my EC2 instance, which is a public instance. Now here I need to make sure that it is connected to the internet. So if I ping say google.com, we are getting proper reply. That's all. Now I also need to create a private instance in the private subnet and check the internet connectivity from that instance. Since we are using NAT gateway, we want to make sure that NAT gateway is working fine and even a private instance is able to connect to the internet. So we are going to create a private instance in the private subnet. And here we need to make sure that we use proper VPC and custom private subnet. And here the subnet setting is disabled. Now we want to keep it disabled. We don't want this time to have a public IP for our private instance. So we'll keep it disabled. That is a major difference between creating a public instance and a private instance. So I'll go ahead. I'll write the name. My private instance. This time I'm going to use the same key pair and then launch the instance. I can see my instance here which was created. So we can see here that now we have got two instances, one public instance in the public subnet and another private instance in the private subnet. Now here you can see the zone also is different because my both subnets are in a different zone. So if I just select my private instance, now here we can see that it has not got any public IP. So if you don't have a public IP, how do you think we are going to access it, right? Because in the putty, we always give the public IP and that is how we connect to it. So we cannot connect to private instance directly from our laptop because private instance doesn't even have a public IP. And this is what we desire. We don't want any internet client to have direct access to our instance. So this is by design. But having said that, any of our EC2 instance within the same VPC can still connect to this instance. So what we can do is we can jump to our public instance, and from the public instance we can connect to our private instance. But we would have a dependency. We would need the key pair file to connect to the private instance. So what we are going to do is we are going to copy the PEM file first on the public instance, and then from there we can use the key pair file to connect to our private instance. So for copying file to your virtual machine, we use WinSCP. WinSCP is again another tool similar to PuTTY, but it is used for the file transfer. So what I need is I need to connect to my public instance. So just give the public IP here, or we can also give the DNS name, username EC2-user. And in the advanced setting, we need to provide the authentication. This authentication is about the public instance. So we are providing here PPK file at this stage. Once done, we can log in into it. Yes. And here you go. On the right hand side, we can see our virtual machine, our public instance. And on the left hand side, it's my laptop. So I can now copy the key pair files, that original .pem file that we had in our public instance. So here in the AWS keys, I can find my .pem file. So here it is, my Singapore key pair.pem. I can just drag and drop it here, and that gets copied. Now this is going to home EC2 user directory. So once done, I can just close it. And now when I go to my public instance, there you go, I can see my Singapore key pair.pem file. Okay, so our objective here is to connect to the private instance. So to do that, I just need to do a few more logistical things. Here we need to change the mode of the file to read only. So I can do chmod 400. And now I can use this PEM file to connect to the private instance. Just clear it up. And here I can use ssh-i, the PEM file name, the username, @ the private IP address of the private instance. So I can get that from here, 10.0.1.218, and here you go. Just say yes. And you are connected to your private instance. Now whether it is connected to internet, we need to check that. So I can do ping and www.google.com, and you can see that we are getting a response from google.com, which means it is now connected to internet. We can also make sure by downloading some files. So if I can do yum install httpd-y, we have to be root for that. Su to enhance my privileges. Now we can do yum install httpd-y. So here you go. It connected to internet, it downloaded the package and installed the package. So what all we have done, we have created a VPC with two subnets, one public subnet and one private subnet. We have created a NAT gateway inside the public subnet, and we have seen that in the route table there is a proper entry to it. And then we created a public instance in public subnet and a private instance in the private subnet, and we have verified that both of them are now connected to the internet. From private instance, it is just a one-way communication, which means only the private instance initiated commands will work. For internet initiated requests, there is no public IP for the private instance, so it cannot be initiated. So this concludes this lesson. If you have any doubt, any query, just put a comment in the discussion box and we'll get back to you. See you soon in the next video. Thank you for watching.